delighted to welcome you all to today's webinar on the topic Enhancing Casting Quality and Productivity through Optimized Methoding Solutions. We are happy to have you joined us from across the country. We believe today's session will offer valuable insights, spark meaningful conversations, and leave you with fresh perspectives to take back to your work. I now request our chapter chairman, Mr. Sandil Kumar, to welcome the audience, please.
Good afternoon, fellow foundrymen. On behalf of IIF Chennai chapter, I am delighted to welcome you all for today's, I think it is our fourth webinar on the subject of enhancing casting quality and productivity through optimized methoding solutions. I think the quality and productivity is the two parameter which is always demanding from any industries, and everyone is trying to achieve this every day. How better we can achieve it. In foundry operation, methoding plays a pivotal role. It's a bridge between the design and defect-free production. Generally, the well-optimized method not only ensures the dimensional accuracy and also the soundness of castings, it also helps to reduce the rejections and improve yields and enhance overall productivity. I think by increasing the customer demands and then the range of tight tolerance and competitive pressures, I think we have to use a lot of methoding techniques to support by simulation tools, and we can reach out betterment. I'm sure that today we have a speaker, Mr. Rohan Joshi, Senior Manager Application Engineering and Methoding from Foseco India Ltd, and Mr. Nitin Patil, is a Solution Manager and Methoding Foseco India Ltd. I'm sure that the rich experience and ideas would help us to get more knowledge on this particular area. I also would like to thank this moment for our annual sponsors. Chennai chapter has approached many of our sponsors. Many of our people have contributed for annual sponsorship. We would like to thank them for this particular moment. And I'm sure that this session would bring a lot of takeaways. I look forward to have very active interaction sessions. Thank you once again. All are welcome to this session. Thank you, Raj. Over to you.
Thank you, sir. Now I request Mr. Vignesh Ramanan, our immediate past chairman, to introduce our speakers for the day to the audience.
Very good afternoon, fellow foundrymen. It gives me immense pleasure in introducing our two eminent speakers of the day to the audience. The first speaker for today is Mr. Rohan Joshi. He is currently the Senior Manager, Application Engineering, Iron Methoding. He is a qualified BE Mechanical Engineer with over a decade of experience in foundry methoding. Mr. Rohan has been instrumental in providing advanced simulation and methoding solutions to more than 250 iron segment customers across India, and combining simulation accuracy, on-ground practicality to drive customer success. His expertise lies in integrating cutting-edge technologies such as FeedX HD and CalPOR, particularly in new product development and casting method optimization. Mr. Rohan has collaborated closely with the OEMs and foundry clients across a wide range of sectors, including automotive, construction, equipment, general engineering, hydraulics, railways, and power. He has previously delivered engaging, insightful sessions on methoding advancements at various chapters, Westcon, OEM supplier meets. A warm welcome to Mr. Rohan Joshi. He has also earlier presented in one of our Chennai chapter programs also. Now it gives me immense pleasure in introducing our second speaker for the day, Mr. Nitin Patil. He is the Solutions Manager, Iron Methoding. He is a qualified BE Mechanical Engineering graduate and also holds a degree in MBA Marketing. And since 2010 to 14, working for a renowned iron foundry, gained hands-on experience in methoding and developing functions, laying a strong foundation in process design, gating rising system, optimization, and metallurgy. From 2014 till date, with a background in diverse techno-commercial roles, He is now leading iron methoding solutions for the Indian foundry sector. His work emphasizes value engineering, innovation, and customer specific problem solving. He has extensively implemented metering solutions that have delivered exceptional value to Indian foundries. He has developed and commercialized next generation feeding systems and metal filtration products, delivering measurable improvements in casting quality, cost, and operation efficiency across multiple sectors. With over 15 years of progressive experience in the uh, metal casting industry, he has implemented a strategic approach to methoding to deliver tailored technical solutions, products, toolkits that address the evolving needs of India's many leading foundries. Gentlemen, we are indeed very much blessed to have um such eminent speakers amongst us today. Let's put on our thinking hats. The floor is open to Foseco people, please. Yes. It's muted, Mr. Rohan.
So your voice is
It's
not
still not.
audible.
Yeah, still not audible.
You're not audible.
You know,
Yeah,
it's
now
okay.
it's okay.
No,
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 we
no,
could
no.
not hear you.
It's not audible.
आवाज येतो नितीनचा
I think Dinesh or Sailesh can get in touch with the speakers and fix it up, please.
Shailesh,
Sailesh?
Sir, yes, sir. Will call
Please
him.
talk to Mr. Rohan.
Yeah, okay.
have you checked their voice? Sorry, gentlemen, I think speaker is checking his voice. Please bear with us for another 2-3 minutes.
Hello? 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 Hello?
Yeah. Yes.
Now audible?
Yeah, you are audible now.
Hello? Hello? Hello?
Yes, boss. Yes, boss.
Audible now? Audible?
Yeah, you are audible now.
Okay. Thank you.
You may please start the presentation and go ahead.
Okay. Yes. Hello. Good afternoon all. Sorry, because of we are in office and the link is not opened in our office. So we are using personal laptop and we are facing major challenges with respect to personal laptop. So sorry for that. And first of all, thanks for joining all the colleagues for all the Foundrymen for today's session. Myself, Nitin Patil, and today my colleague Rohan Joshi will explain on methoding solutions, majorly topic related to improving quality and productivity through optimized methoding solutions. So, as we know, first, we know Foseco is preferred foundry supplier, and we are well-established brand, and majorly we are supplying major products with respect to feeding, filtration, coating, binder, non-ferrous also, and FMT. So we are having all portfolio required for foundries. So our presence, we are having global presence. We are having global R&D in Enschede, corporate office in UK, and our presence is more than 40 countries. So strong technical database. We are having all technical teams with all product backgrounds. So as you know, in foundry, consistent quality is most important. So we are providing products with consistent quality, and we are having strong supply chain, all sales team available at regional levels across all everywhere in India, and we are having warehouses. From that we will supply our materials to the customers. So today we will discuss on majorly feeding system. Major agenda is first we will start with market scenario where we can discuss with current situations. What is the future of the foundry market? After that, we will discuss on feeding system and riser thumb rules. Then we will discuss on Foseco offerings related to which sleeves, Kanpur sleeves, regular sleeves, and FIDE HHD sleeves. After that, we will discuss on comprehensive approach for methoding, and then we will discuss on specially Foseco methoding support with Foseco Pro model. So we will start with market scenario.
One second, Mr. Nitin. Somebody else has started their training. Mr. Dharmendra requesting of sharing, please. Mr. Dharmendra, sir. Sir, please stop sharing, sir. My God, a lot of people are sharing the screen, Mr. Sendil. AI engineering has started sharing. Sir, requesting members to please stop sharing, except the speaker.
Sir, you can change those settings, I think so.
How the settings will be. Shailesh,
See,
Yes, sir.
you should allow only speaker to
Share. Okay.
share the screens.
I think Foseco team can still try to share the screen actually, so automatically it pops up.
No, what I'll do is I'll make AIA as an attendee so that they will not be able to share this thing. Present. Is that okay?
Yeah.
Yeah, it's fine.
It's
Please
now
go ahead.
visible?
Yeah.
Yes, yes.
Thank you. Thank you. Thank you.
Please go ahead, sir.
Yes, assistant. So, as you know, iron foundry has grown by 6 to 8% over last decade and expected to grow by same space, I think more than same space. So, Make in India initiatives from Government of India and various infrastructure development and improving consumptions, which will further expected to grow more. So there are various government policy which will help us to grow. And as you know, in India, we are having more than 4,000 foundries and the market is very competitive and fluctuating raw material and energy cost is the major challenges for all foundrymen. So these are the current market scenarios. So now OEM demands. The OEM major demand is faster development now. As you know, before past 10-15 years back, OEM development time is 3 to 4 months. Now OEM expectation is they want new product within 130 days. So their expectation is first time right and time is also reduced. Second, tightening quality requirements. In earlier, now Euro norms change, casting geometry change, isolated hotspot, milli for value for cylinder head block and cylinder head castings. So because of this quality requirement, radiography level NSD requirements, that are also new expectation from OEMs. On-time supplies, it's always there, and justifiable cost. Now, because of competitiveness, we have to reduce the casting cost. That is a major challenges for all foundrymen, and so OEM demand is majorly same. So related to OEM demand, foundry expectation is with first measure is quality. So good quality cost casting. Second one is productivity. For productivity to improve the yield, reduce the rejection, which is important, optimize production cost, and the simplification of process. So to match OEM demand, now it's very important for foundry to improve quality, productivity, reduce cost, and the process control. So all these parameters are important to satisfy now the OEM demands. So impact of quality and productivity on foundry performance. So as you know, suppose there is a method A, suppose and good melting is 100 metric ton. In that yield is suppose 60% and rejection is 10%. So foundry output is 54 metric ton. And with method B, same melting is 100 metric ton. We have improved the yield by only 5% and controlling rejection by 5%. So foundry output is increased by up to 62 metric ton. So that means total foundry output is improved by almost 50%. So this is the case, special case, one of the case study where this is the end cap casting where customer using conventional sprue bar, sand riser, and grade is Agent 500 by 7 grade. Casting weight is 500 kg. Number of cavity is 2. Current bench weight is 18. Current bench weight is 18 kg. So with this method, we have suggested customer to use Kalpur sleeves to avoid the shrinkage also, neck shrinkage, and it will improve the yield. So you can see with this rejection is from 12% reduced to 8%. Further work is going on with respect to reducing inclusion of sand, but bunch weight from 18 kg reduced to 14 kg. 4 kg saving in bunch. That's why that foundry will supply 65,000 numbers quantity to customer in time. So yield is also improved, rejection is also saved. So that's why they will save their cost, increase productivity, and increase yield. So this is the case study from one of the Eastern sector. So total 35% increase in foundry output with this. Impact of pricing. as you know, risering is most important parameter. So impact of riser in quality or productivity. So as you know, risering is integral part of foundry process, and to achieving the quality standard expected from OEMs, this is important part. Then production consistency and to control the rejections, to improve the yield, methoding yield. Ease of operation means to reduce the fettling cost, to save the fettling time. Currently, we are facing major challenges with respect to fettling. To save this time and to supply casting in time, so methoding is important part. And then customer trust. So these are the major impact with respect to risering system design. But how to implement it and how to improve the performance of the foundry? So what are the aspects? Can anyone tell us what the aspects to consider while designing the risering? We will make this session slightly interactive. So anyone?
Hello.
Yes.
It is modulus of the casting and volume to be feed.
Yes. Correct. Anyone? Any other aspects other than volume, modulus?
On a lighter note, there are no negative marks to this.
Wall thickness of castings.
Yes, correct.
Metallurgy being poured.
Yes, great, correct. So modulus, volume, metallurgy, wall thickness. So these four, if we can see now which are the aspects to consider for designing the risering system. First one is casting geometry. So depend on casting geometry, we will select the risering system, whether the top riser, side riser, we can decide. Then requirement of RT, whether NSD level 1 is acceptable in some section or level 2 is acceptable, depend on that, we will design. Then pattern space utilization, better utilization of pattern space. That is also depend on pattern space also, we will select the riser. Casting orientation, core print, mold print also there, some molding lines. Some molding lines don't have access to for insert the sleeve application from parting line, because now currently high productive lines like Disamatic, the pouring box, molding speed is 300 numbers per month, per hour. It is very difficult to place the sleeve. So depend on that also, that will also affect the risering system design. Then type of riser and placement, whether side riser, top riser. So these are the various aspects to be considered for the risering. So why feeding? As you know, the feeding, or you can say some risering system design, is designed to avoid the major shrinkages. The shrinkages are neck shrinkages, internal shrinkages, and machining shrinkages. Machining shrinkages are opened after machining, so rejection after machining involves more cost. It will add machining cost also. Why sleeves? So generally customer earlier using sand risers, so it is additional reservoir called riser is required to casting to feed extra metal to avoid the shrinkage. But additional sleeve application on sand riser can reduce the sand riser considerably. If you see, instead of sand riser, if you replace the sleeve with very good MF, that will save your 70% of metal. That we will see in the next couple of slides. But that's why sleeves are very important. As we know, sand riser efficiency is 10%. And if you use conventional exothermic riser, where efficiency is 33%. And if you compare sand riser of weight 8.4 kg, if you replace sand riser for exothermic sleeves, it will give 2.1 kg of metal. So it will save over 75% of metal. So from 100% sand riser, you can require only 25% of feed metal requirement with the help of sleeve. It is because of only sleeve exothermicity, but sleeve MEF is also important while selecting these sleeves. Feeder calculations. To calculate feeder, can anyone tell what are the major factors, important considerations to calculate the feeder? Only feeder design, not running system. No negative marks for wrong answer.
A location of the feeder where we have to give the feeder there.
Yes, correct. Very good. Okay, so I think last time someone tell about modulus, which is the to ensure the field solidify lives. Last modulus is the volume upon cooling surface area. Screen is visible?
Yeah, screen. I think somebody else is shared.
I
Shailesh,
think somebody has reshared. We need to, I think, share it again.
you shared again.
Now visible?
No, not yet.
Now?
Yeah.
Now I think it's visible. Yeah.
Okay, fine. So okay. So first one is modulus. To ensure the feeder solidifies later, modulus is volume upon cooling surface area. So modulus is the first while consideration of while designing of feeder. Then next one is feed metal requirement. To compensate for the metal shortfall, field metal requirement is important. Feed metal requirement is depend on grade of the casting, whether cast iron, HN, depend on. Request all of you kindly mute your laptop. Hello? Yes, audible, na? Feed metal requirement. Yes. Feed metal requirement to compensate for the metal shortfall. And third one is feeder numbers and locations to feed all the isolated area. So feeder numbers and locations are important. We will discuss one by one. So modulus and volume. Can anyone tell what is the modulus?
Volume upon surface area.
Okay, correct. So modulus is volume upon surface area, and while selecting the feeder, modulus of riser is 1.2 times of modulus of casting. To solidify a riser later than casting and to shift the hotspot from casting to riser, we'll select 1.2 times of casting modulus. And for volume requirement is depend on percentage shrinkage factor of that alloy and feeder efficiency. Feeder efficiency, if there is a sand riser, feeder efficiency is 10%. If it is conventional sleeve riser, feeder efficiency is 33%. And if it is high density or you can say spot feeder with higher MEF, the feeder efficiency is 50%. Suppose, for example, this is the example where if the casting weight is 10 kg and shrinkage is 4% in HN, normal HN, which we have considered, and feeder efficiency is 50%. So final feeder weight is 800 grams. So for 10 kg of casting, feed metal requirement is 800 gram in case of high density, highly exothermic material with the help of highly exothermic screw. So this is the modulus and then volume. So modulus, as you know, volume upon cooling surface area. This is the one example of sphere where modulus is volume upon cooling surface area. Volume of cube is pi d cube by 6 and perimeter of cooling surface area is top surface. So modulus is d by 6. Similarly, like cube, we have calculated it's a by 6 for cylinder. If you calculate modulus is also a by 6 for plate, it d by 2 for rod. So casting shape is like a square rod, then it's a by 4. And if rod is round, then it's d by 4. So these are the various modulus calculations. And sometimes we need to calculate modulus for particular section. So for particular section, particular area, it is area by perimeter. Suppose A is length and B is thickness, then modulus is A into B divided by 2 into A plus B. And C is non-cooling, which we have considered. That's why A into B divided by 2 into A plus B minus C. Now we'll discuss on volume requirement, and which is also depend on feeder efficiency. So which would currently we have discussed sand riser 10%, conventional exothermic 33%, and feed HSD 50%. So if you consider depend on the riser which we are selecting, which will improve your productivity or you can increase your yield percentage depend on sleeve, whether you can use conventional exothermic or feed HSD. Riser location, hotspot connection, and neck size. You know the riser location, hotspot, and neck size is important factor while designing the running system or feeding system. There are these are two cases where you can see first case is riser is slightly offset and second case is riser.
I think some people are still not have muted their microphones. So request if you have any questions, then only unmute yourself, or it will disturb the flow. Yes, we'll go ahead.
These are the two cases where first case is riser is offset and second case is neck is cut off, hotspot is cut off in neck. So this is the correct case where hotspot is going inside the riser. So while designing the feeding system, shorter neck length and optimized neck size and neck location is also important. So to avoid the shrinkage. Inside riser also, here we can see the neck modulus is lower. That's why neck is cut off is observed and shrinkage remains inside the casting. That's why proper neck design is also important and neck's length. In side risers, neck length plays an important role. Sometimes during designing some development, some methoding engineer increase the neck length, which is up to 50 mm, but it will in that case neck cutoff is observed and that will cause shrinkage inside the casting. So now in front of you there are three images. Two are wrong and one is correct. Can anyone tell why middle one is correct and two are wrong from your experience?
Riser diameter to height ratio is correct in middle one.
Okay. Correct. So while designing riser system, length and diameter ratio is very important. If L by D ratio is 1:1 or less than that, then shrinkage will go inside the casting, which is first case. In third case, the riser height is more. That's why it will casting is okay, but it will impact on yield percentage. And third one is, so while selecting the riser, L/D ratio is 1.5 to 1 or 2:1. So that is most important while designing the risering system. So foundry process. So foundry process also impacts the shrinkage. So can anyone tell what are the various process parameters which will affect the methoding or which can impact the shrinkage inside the casting?
It's a temperature of the pouring temperature.
Yes, correct. Temperature.
Carbon equivalent in engine.
Correct.
Mold hardness.
Yes. Correct. Okay, thank you. So,
high magnesium value.
yes, correct. Exactly correct. So we will discuss one by one various process variations. So first one is correct pouring time, pouring temperature and time, which will impact. High pouring temperature will increase the shrinkage. Pattern allows us, not as per drawing, more pattern allows us swelling, which this will require high feed metal requirement and causing shrinkage. Poor quality of sleeves and uses after expiry, then that will also impact. And location means displacement of sleeve, chills, and neck size. And last one is C value, magnesium level, and mold hardness. So these are the various process parameters which will affect the risering systems. Now we will discuss on various types of sleeves. First, we will discuss on Kalpur sleeves. So Kalpur is a sleeve where filter is placed inside the sleeves and we can pour the casting. This is used to improve the yield and improve the productivity. And because of filter, it will improve the flow, laminar, and it will trap the slag inclusions. So it is the shortest way to perfect casting, and it will improve the yield and productivity. So these are the major benefits of Kalpur. It will improve the yield. It will eliminate the traditional running system and riser. No need for ingots, running system, sprue. It will reduce the fettling because of no ingots and all. It will reduce the fettling time. Replace current filtration system. Inline filtration system will be eliminated with the help of Kalpur. It will improve productivity, reduce pour weight, and enable running system. It will help to remove the shrinkage, transferring the hotspot from casting to the sleeves. So it will be important. And uniform method. Its ease of application requires, because of Kalpur, no need to calculate choke area, running area, inlet area, whether pressurized getting system, non-pressurized getting system. So with the Kalpur methoding, we can save our methoding time. And it will ultimately, with all these points, we will maximize the profit. So these are the various type of Kalpur sleeves. Depend on molding line, we will select the Kalpur. So first one is Kalpur KSE. This is the Kalpur sleeve. We can insert these sleeves from the parting line. The lines like ARPA molding lines, DISA match molding lines, or any horizontal molding lines where mold is accessible, cope mold is accessible. So we can place this sleeve from parting line. So for that, Kalpur KSE sleeves is used. Kalpur KSP is reverse taper sleeves, which Foseco has invented these sleeves in 2017. So now, because of dysamatic line, their pattern is not accessible. Mold is not accessible. Placing of sleeve is difficult. So in case of Kalpur KSP, we can place sleeve from top after the molding. So this is the reverse taper sleeve which we have developed. So it will save molding time also, and high productive line like disamatic line we can use Kalpur KSP sleeves. Any vertical lines also, horizontal disamatch, Sinto lines also we can use Kalpur KSP sleeves. Kalpur K-set, where this is used for horizontal lines where box height is higher, more than 250 mm, like KW line. These are flex lines where box size is higher. To increase the yield percentage, we can use Kalpur KSCT, where filter is fitted in the top, and Kalpur NT, where we have provided arrangement to place a filter inside the neck down sleeves. So we can pour the casting directly through neck down sleeves. So these are the various type of Kalpur sleeves. And now we can see various case studies with respect to these Kalpur sleeves. This is the particular case of hub castings. So same hub castings, how we can produce with different method systems. So we can see first case. In first case, we have provided riser at the Kalpur sleeves at the top. So from top directly we are feeding the hub. In second case, in core, with the help of mandrel or loose piece, we have provided neck in the core, and from central we can pour the hub casting. And third case, where there is isolated hotspot because of pocket, for that we have given 4 necks at 4 different zone, and with same central core we will pour the hub casting. So with this all hub casting, we can get more than 80% yield. And riser neck is connected near the hotspot. So from outside, it's very difficult to eliminate shrinkage from the hub casting. From inside, by providing neck through or riser through core, it will remove the shrinkage. So this is the major importance of Kalpur with hub for hub castings. So these are the different case study. So first one is for block casting, where regular Kalpur is filling four castings. Second is planetary carrier, where Kalpur K-set is used. This is KW line, and at the top there is a downsprue. From downsprue, metal is poured in the casting, and in Kalpur, and then side neck given to the castings. Third one is bonnet casting, where one Kalpur is provided for 2 risers. This is fourth one is torque plate. The torque plate also we have given Kalpur K-set. This is also horizontal line. So filter is placed at the top of the Kalpur. And last 2 are Kalpur KSP, which is reverse taper. So we can give 4 sleeve for 4 cavity, 1 Kalpur riser. With all of this, we can provide higher number of cavity feeding to higher number of cavity with the single Kalpur sleeves. So now my colleague Rohan will continue with the regular sleeve and FedEx HD.
Hello, everyone. Thank you, Nitin, and good afternoon once again to everyone. So we looked at a very interesting product, that is the direct pour unit. And now moving on to the regular slurry sleeves. And here is the product range available as of now. Over the last 20 to 25 years, we have developed a lot of sizes for this. And these are available in both open cylindrical, open blind, and neck down type as well. And in case of cylindrical sleeves, these are also available with the breaker core type. We have both recipes for this, that is insulating and exothermic. And the dias are ranging from 30 dia to almost more than 300 dia. So what this means is that we are covering the overall modulus and volume requirement range for both iron castings and steel castings. And depending upon the size, we have nomenclatured them in different way. That is Calmin 100 plus, Calmin X108, Calmin 91, and Calmin X41. So that is about the overall product range. And whenever we are going for a method of the casting, specific to a pattern, specific to modulus requirement, we can make utilization of a particular size of that sleeve. So now let's look at the different type of applications that are possible for these kind of sleeves. Firstly is the insert application, and this is specifically used for riser sleeves which are with the breaker core and as a top riser. So here you can see clearly that once the mold is prepared, there is a cavity into which the sleeves are fitted in and the box is then closed. So this is called as insert application. The opposite application to this is that of ram-up application, wherein the sleeve is placed onto the pattern and then we go for squeezing and molding. And this is how, in the end, the riser sleeve application will look like. So these applications, if you see, there is one common thing between the ram-up application and insert application. Can anyone identify for me what is the common? What is the common point? In case of insert, we are placing the sleeves in mold, and in case of ram-up, they are placed in on pattern. But there is one common thing. Sorry, anyone?
Insert peg. Peg. Wooden peg or.
Sir, I didn't get you. Could you please repeat?
Arrangement is during the pattern.
Two people joined in together. One at a time, sir, please.
Arrangement of
whatever is planned should be whatever is planned should be done in pattern itself first. That is important.
That is correct, but for pattern we go for ram-up application. Here we are going for molding. So I'll just explain. It is a small thing that in both the cases, draft of the sleeve. Yeah, draft of the sleeve is same, correct? The main aspect with respect to pattern is that these sleeves are placed on a flat face for insert application. If the casting face or wherever they are placed is not flat, this kind of application is difficult. That is the main point here for such kind of sleeve application. So this is one part. Then moving ahead, as we have seen for Kalpur, even these regular sleeves can be placed through core or placed on top of the core and feeding can be done through it. This is third type of application. Then one more application which is getting more useful in flaskless lines where the coop mold is not accessible is placing of sleeves in the drag mold. What we call this as a closeover application, wherein the sleeve is placed in drag and then the coop mold gets closed over it. A small groove of around 3 to 5 mm is created in the drag mold so as to lock the sleeves in that place. So many customers using DISA match or Sinto lines, flaskless lines, are using this kind of methodology. Here is an example of shell molding, wherein the sleeve is placed at the parting line, or we can say in between the two cakes, as you can see here at the top, or even in some cases as a top riser. And some loose sand is also filled in so that the sleeve does not break after pouring. Similar application we can find in vertical line as well, wherein the sleeves tapered downwards can be placed from the mold top. And the other application for vertical line is placement of sleeve through the core mask. Now, especially for cored items, core setting is required, and based on that, even sleeves can be fitted into the mold at the same time. And in case of mold top application, we need to consider that the draft of the sleeve should be downwards. That means the OD at the top should be higher, and that way only we would be able to place the sleeve from the mold top. So considering all these applications, you can clearly see that there are three locations wherein we place risers. That is at the parting line, as a top riser, or at say at the cake area, or say in between, or through the core. These are the three areas wherein we place the riser. So whenever we check for feasibility of risering, it should be done at the development stage only. So based on that, we can go for the correct parting line, correct casting orientation, and also the correct core prints. We actually experience a lot of customers having shrinkage issues, but now as the pattern is ready, they cannot go for modifications, and in the end, risering feasibility also is an issue, and hence they have to work out for higher rejections, and that again leads to lesser productivity or issues over cost pressures for the foundry. So whenever, if the casting is method or feasibility is checked initially with respect to parting line, core print and stuff like that, risering feasibility becomes more easier, and hence problems like shrinkages could be avoided at a later stage. So let's look at a case study for such sleeves. And here is a first example of wheel-up casting, a very small casting of 2.7 kg. And what we here we have done is just eliminate the sand risers and use of insulating Calmin 100 plus 4x7 sleeve. The gating system is kept same. The orientation, the riser locations is also kept same. We are using 2 risers per casting, and same is kept with the new insulating sleeve method. What we achieved was around 5 to 6 kg of metal saving. And this kind of metal saving will always be an additional benefit apart from the any other cost savings related to fettling or say the remelting cost. So overall, we achieved 13% yield improvement in this. One more similar case study, and this is for a automotive bracket. Here again, we went from sand riser to insulating riser, that is Calmin 100 plus 4x7. And here actually we achieved a higher yield saving of around 8 to 9 kgs. So again, a similar case study, but there is one catch in between these two case studies. For this bracket casting and for this front hub casting. Can anyone spot for me that? Yes, we have gone for yield improvement, but there is one more catch, which actually helps us to understand, optimize. Exactly, RT level. In first case, the RT level 1 was required. So we had to go for optimization based on that. That means we could not, we should have avoided shrinkage in the casting. And that way we need to consider the optimization, that whatever riser we are fitting in, it should not result in affecting the soundness. In this second case, you can clearly see in both the images with sand riser and even for the insulating riser, there is shrinkage tendency predicted in the casting. And based on these results only, we went for optimization, and that again is calibrated with the actual trial results. If level 3 is accepted, and based on that, that calibration is done on simulation, and thus we went for actual trials and went for the optimization of riser. Now imagine if I went for optimization, but I went for improving the soundness as well. In that case, I would have required to go for a higher size of riser, which again would not have resulted in any fruitful point in terms of yield. Yes, we improved the soundness, which was not required, but we also did not improve the yield or optimize the overall method. That way, we need to combine both together, the casting quality and productivity. So any doubts up till now, or we can move ahead?
Rohan,
Yes.
is there any specific reason to use the Kelvin sleeve here? Because we can use Kelvin X also, na, for this type of casting.
Yes, yes, for sure. But again, that depends on the cost as well. So based on the combination of cost
Okay. Yeah.
and customer preferability, we went for Kelvin 100 plus. But sure, yes,
Okay.
we can think of riser reduction with exothermic sleeve as well.
Okay.
Yeah. Now moving ahead. If anybody having any question?
Anil Shukla from Shivalik.
Yes, sir. Yes, sir. Tell me.
How to calculate this in level 3 in hotspot?
Your
You
voice
mentioned
was.
in level 3 how to calculate it.
Huh.
This is level 3 is shrinkage.
That is a calibration of actual trial results and simulation. So based on experience, we have to calibrate the simulation software, and that is how we go about it. Directly, we cannot say judge out. Only there is, yeah, simulation will only give the probability. But calibration we have to do. Yeah.
Okay.
Yeah. So moving on to something innovative. And here are some examples of casting. Can anyone tell me what comes to their mind in terms of directional solidification or solidification pattern in these castings? What challenges they see?
To feed at different junctions.
You mean to say isolated hotspots?
Yes.
Yes, that is one. Any other aspect? It is similar to isolations.
Irregular parting line.
Yes, that is also there, correct. Mostly you will agree that all these castings will be produced on green sand high pressure molding lines. So first, as we had earlier discussed, that the OEMs are reducing the casting weights, which generates more isolated hotspots, and there is less space for on castings to place the risers. And upon top of that, we have our constraint of molding lines, high pressure molding lines. And thus the riser has to bear in the squeezing pressure as well. So considering all these aspects, spot risers were designed mainly, firstly, to withstand the squeezing pressures. Secondly, to be able to place on the smallest footprint area on the casting. And most importantly, to provide soundness in the most complex part in the casting. As the saying goes, feed where you need, and that too with the ease of application. FeedXSD application is quite common these days, and most of you might be knowing it is a simple locating pin application over which the sleeve is placed while molding. And this is how the feeder looks like, and the knockoff of feeder would be very much minimal. So typically, we have discussed the yield part, but still I'll reiterate it. In terms of sand riser to feed XSD, if we see the conversion or say the yield improvement which we can achieve from 8.4 kg sand riser, we can go up to 800 gram of sand. That is just 10% of the conventional sand riser weight. And not only that, we are also improving this riser efficiency from 10 to 15% to almost 50%. The second aspect is of feedling and cleaning work. The maximum riser neck size for feed XSD is around 30 mm, and most of the risers are hammered out easily without any requirement of cutting or feedling work. And the most important aspect is feeding the isolated areas which cannot be fed by any other options. Now, typically in foundries, if you find that we are providing heavy padding at the neck areas, we are providing heavy sand risers or sleeve risers as side riser, chills we are using, or say sometimes we are using the profile breaker cores. Not only are these operations very tedious, but they also result in inconsistency in the methoding, or rejections levels are quite high in such cases. And if we are able to replace such tedious activities by simple pin application, then definitely we are improving the foundry process, improving the productivity of it. So overall, if you see, it is a product which provides multiple benefits. It will provide you with the highest possible yield, and you can provide the riser at the smallest footprint area, and thus provide soundness to the casting. And typically, if we consider the current scenario of high casting quality demand, the molding line constraints, and the benefits that this product provides, it has definitely gained a lot of pace, and most of the foundries are now using for producing high quality castings. Now moving on to some case study related to it, we saw some drastic changes in the yield with FeedX HD application. But how does it translate in actual casting? And this is an actual case study which will show you or showcase that effect for you. In this castings, the cavity, it is a 2-cavity layout, and firstly, the method was a side riser method. And the bunch weight was around 261 kg. And this is a 10 by 13 side riser. We converted into a top riser, and in fact, we increased the risers considering the hotspot and covered all the hotspots to produce NSD casting. And in turn, the bunch weight reduced from 261 kgs to 197 kgs. That is almost 60-65 kg saving per box and 30 kg per saving per casting. So not only we did maintain the soundness of the castings, but we were also able to improve the productivity as well. Another similar case study, these are automotive brackets produced by different foundries and across all over the world. But one thing is common, that all of them are preferring to use spot riser methods. And this is mainly for consistency of the methoding. So that is it about the products. We covered Kalpur, the regular slurry sleeves, and spot risers as well. But now the $1 million question is, you have told, Rohan, you have told all the type of sleeves. You have shown us that all give us 80% yield. But when we are methoding the castings, which sleeves should we select? Or how do we go about creating a method? So there are 4 aspects we need to consider for optimizing our methods. Firstly is we need to understand what is the quality requirement of the casting and what kind of consistency we are considering. Secondly is the process feasibility. That is the molding line, the pattern layout and orientation we are trying to keep. The third part is how we are going to introduce ease of operations in the methoding. What kind of yield, what kind of productivity we are targeting, and how we can reduce the fettling time as well by optimizing our neck sizes. And all together, at what cost, at what price, or what cost of overall total methoding we need to consider. So always we need to find the right balance between all these parameters: quality, feasibility, ease of operations or productivity, and at ultimately justifiable cost. So let's take an example to try and understand how a method person should go about methoding a casting or optimizing the method for it. So here is an example of an axle housing case study. And this is these are the three methods which we can consider. One is of sand riser, which is having bunch weight of 54 kg. And we are getting RT level 3, which is quite acceptable. And then here is a second method wherein we are using 2 spot risers and 2 5x11 risers. There is a yield improvement of 6 kg. And in fact, we are achieving RT level 1. However, the OEM is considering only RT level 3. They are not requesting for RT level 1. And in the third method, we are adding one more 5x11 risers and achieving NSD level casting. So considering these points only, can anyone come up and share your experience? Which method you will prefer for your foundry? Which will be the method which will give you quality and cost effectiveness?
Second method.
Second method. And you need to explain why as well. Why you think that second method will be giving you cost-wise and quality-wise better result?
The yield is almost 80%, and we are at a par with respect to the customer requirement for RT level, and definitely it's suitable for our molding line. So that will be the consideration for second method.
So in terms of say first method and second method, you'll prefer second method for better quality and consistency.
Out of three, I'm preferring second.
Okay. Any other one who is preferring the first one?
It will depend upon the cost of the riser, I think.
Exactly, correct.
Maybe
That is the point.
70 to 79 kg, not much difference.
Yes. So if you consider the bunch weight, there is 6 kg difference. Yes. But we are introducing 2 spot risers as well. Of course, we are improving. Yeah. And of course, we are improving the
Actually,
casting quality. Yeah.
Challenge is there that placing of riser requires labor or worker to do that job. That is also one additional cost. Whereas our pattern itself, that cost also we need to consider in the long term. That is what is my opinion.
Yeah, that is just one aspect to it. But yes, we need to consider that result. So yes, if you consider, even when with method 2, if we are achieving RT level 1, but the acceptable is RT level 3, and 6 kg difference of metal will not compensate for the extra cost of the risers. So preferably, people will prefer for the sand riser method, considering these points only. Now let's check with some other changes that are happening in the foundry. Now, for the first method, the shrinkage percent is 15%. And for the other two methods, the shrinkage tendency is below 4%. Now, which method you will go for and why?
So again, we'll have to go for some calculation only. But maybe with this additional input, I think so second middle method is preferable.
Yeah. So now you are in dilemma that the extra cost of 15% plus the 6 kg metal saving, will it be compensated by the cost of sleeves? That is how we have to look for it. But now I introduce a third parameter that initially you are producing just 500 numbers, that is around just 20 tons of good castings. But now the requirement is of 15,000 numbers. That is almost 600 metric ton. imagine that the foundry capacity is just around 1,000 to 1,500. That is almost 40 to 50% of your casting production capacity. Now you are required to produce this casting, then definitely it will be either option 1, option 2, or option 3, because you have to manage the productivity as well. It is not just about say managing the quality, but also the productivity, as in because you are reaching near to the foundry capacity. And there is, say, now the last googly an OEM gives us, it increases the RT level from level 3 to level 1. Then which method we'll go for?
You have left us with no
We
option, sir. Now this
we,
we'll have to
we
go
should
with second
consider,
option.
we have to
Which one?
consider about the fettling cost also, no?
Yes, yes.
So second one is the best.
Yeah, but in case of second one, yes, we are achieving RT level 3, but say in for consistency in production, NSD is better. The second aspect is that we are just introducing one more side riser, which is of very limited cost. So even with that, if you are achieving NSD level and giving good consistency to our method, definitely in higher production, higher volume castings, then method 3 is actually preferable. And this actually happened in one of our projects with a foundry, wherein firstly they were producing with sand risers. Our initial production was just around 500 numbers. Hence, they kept on with their conventional sand riser method. But when the OEM demanded for higher number of castings, they requested methoding support from us. And this is the method they went for. Again, further, when the OEM shifted their demand from RT level 3 to RT level 1, we had to introduce one more riser of 5/11 in order to address all the hotspots. So that is how optimization of methoding in practical way occurs. It is a combination of quality, productivity, how many number of castings you are going to produce, the molding line, and in turn at what cost. So if you see this overall example, it is not always the price of the sleeve that plays any role. It is the cost of methoding that decides the cost effectiveness of your method. And that is how Foseco also supports its foundry customers with methoding solutions. And we also have Magmasoft for this. We have 3 licenses in total, and we cater to around more than 200 foundries in a year together. So now coming to the last part, and that is of how effectively you can use simulation in methoding. So I'll divide this in 3 parts. First is the data or the problem statement, then the method and simulation part. We need to go for number of iterations, and finally we need to compare the existing results with the tried out or the best possible iteration, and compare out and then go for final trials in actual production. So first point is very critical, that is data. We need to identify the correct problem, correct statement of improvement, and based on that only we'll decide to carry out the number of iterations. And here we need to consider all the feasibility aspects, try out different methods, and thus come to a conclusive optimization, which will yield better results than the existing one. Or say if you are going for a new product development, you need to try and optimize the method that way. The first and foremost is the correct identification of objective or problem, and the second aspect of simulation. And in simulation as well, there are two aspects like the calibration that we talked previously, calibration of actual results with the simulation. And secondly, for this calibration, we need to have the correct riser performance in what it actually happens, and that should be replicated in the simulation. And for that, Foseco has developed the Foseco Pro module since 1996, and it is a 3D model library of all the sizes of sleeves and filters. Not only the 3D models, but also the thermophysical datasets for replicating the sleeve performance in the actual simulation. So the main purpose or main benefit which we derive from this is of improving the simulation accuracy. And secondly, it also simplifies the method person job. It helps him with the modeling, ease of modeling. And this third aspect is that all these data sets which are assigned to the sleeves are automatically assigned once we select the correct size. So we need not have to worry about the manual error while setting up of the simulations. So overall, if you see, simulation is a key leverage for methoding, and not only it helps in optimizing our methods, but also improves our decision making, finding out the root cause and thus take the correct decisions. Now, with respect to Pro modules as well, for India, all India products, it is available in the Pro module database, right from spot risers to the regular sleeves and even filters as well. So that is it from our side. We covered why and how productivity is important, quality is important, and what is the current market scenario, which makes these two aspects very critical for foundries. Then we looked at the theory behind the riser calculation. We looked at the different types of sleeves, their application, their case studies, and what kind of improvement they can bring for foundries. We looked at a case study wherein how we can look at methoding as a comprehensive outlook towards it. And finally, we also looked at the methoding support and the Foseco Pro module that we as a team can provide for our foundry customers. So that is it from our side. Again, thank you all for joining and giving us time for such a engaging session. And now the floor is open for question and answers. And even if you want to share any experience, definitely you can come up.
Hello.
Thank you.
Hello, I'm calling from Sangli, Maharashtra. Can you hear me?
Yes, yes.
Hello.
Yes, yes.
Hello.
Audible.
Okay. We are handling nickel-based alloys like Hastelloys, Inconel, and Monels. So for that, what methoding or what type of gating system you suggest? Whatever I heard is meant for cast iron, HGN, and plain carbon steels. But I feel you have never dealt with the duplex stainless steels, super alloys, and super nickel based alloys. Can you highlight in those areas?
So in a broader view,
yeah,
for gating system, you can go for, we always suggest to go for non-pressurized gating. And for these high alloy castings, we have a separate team for steel.
Okay.
And just to give a basic understanding, the shrinkage tendency is upwards of 6 to 10%.
Yes.
So based on that, we need to go for risering. But yes, the thumb rule remain the same. That is the modulus calculation, volume requirement, and feeding distances.
Correct. Thumb rule remains the same. Methoding remains same. What we have felt that height to diameter ratio, instead of 1 to 1.5, we are going to almost to double. Secondly, we are using double insulating sleeves. So density is higher and coefficient of the thermal efficiency is very less. So we have to keep the riser at a very hot for a slightly longer time. That is what we are facing the problem. We are calculating as per methoding. We are calculating as per software with the Microsoft only modulars, but our system has not been incorporated for nickel-based alloys. So the new simulation method has to be incorporated all types of materials like nickel and copper-based alloys. This is one of the lack, and if you simulate from that one, we are ending with the wrong results.
Okay.
Hello.
Okay. So yes, sir, this looks like a specific problem. So
Yes.
definitely we'll get in touch separately, and we have our separate steel methoding team. So we'll collaborate together. Yeah.
Okay, no problem.
Yes.
No problem. Thank you.
Okay. Thank you, sir.
Hello.
Yes.
Hello.
Yes, sir.
This is what should be the ratio or relation between the casting modulus and the neck modulus?
So ideally for SGR or iron castings, typically we keep it around 0.5 of the casting modulus. That is the neck modulus. But this is just the thumb rule, and it always depends on the connection, how we make to the hotspot, what is the length, what is the neck length happening in the methoding. So all these parameters also play a role, and maybe we can fluctuate it from 0.3 to almost 0.8, 0.9 as well. But as a thumb rule, you can go for 0.5.
Top riser. If the riser is top riser, then
for top risers, it can be reduced further. We have sometimes worked around 0.3 to 0.4 of the casting modulus.
okay.
Generally, we are adding risers. Mostly, I'm talking about side risers at the heaviest section. So, is it the correct way, or we should have some consideration?
So the best possible way is top riser only, because with side riser, you will have to give a small metal well and then connect it through a side neck. So that adds up the metal and reduces the yield. So preferably, we would suggest to go for top risers. But again, that if the casting geometry is difficult to place any riser, then we have to go for side rise well, like for differential case casting. Most of them are produced as side riser with Kalpur.
Yes, sir. And another thing is again the cost, because if you are going for top risers with HD sleeve, then it is going to affect the cost, because the rate of HD sleeve are much more higher.
Yes. What you need to work out is the cost of methoding, not just the price. What kind of benefit you are getting, what kind of soundness you are getting, and what kind of quality requirements you are matching. That way you need to consider. And definitely means in some cases, like say if the casting is just 1 kg and you are providing spot risers, is not feasible in terms of cost.
Yeah, because feasibility is and all these things we consider, but the costing is based on the customer approval. So in that case,
yes.
Generally we try to get in a side or a top riser, and we avoid the HD sleeves. So I think we should request for the best possible reduction in the costing of HD sleeve, so it will have popularity and will get consumed more in foundry practices.
Yes, sir. But there is one more development is going on, which is with respect to in between slurry sleeve to HD sleeves. So definitely, if that after that development, definitely HD sleeve we will reduce the HD sleeve cost. But currently HD sleeves are feasible where it is very difficult to feed casting from site, the shrinkage location, casting geometry. So there are some cases where it's very difficult to feed casting by side riser. So at that location, only option is HOD sleeves.
Okay, sir. Thank you. Got your point.
Okay. Okay. Thank you.
If there are no more questions, then we can conclude.
Thank you.
Any more questions?
No, we
Okay,
only
sir.
need
I
to
think that's
study. We need to study only on a present in market duplex stainless steel, super duplex steel, and nickel bus alloys. Anything newly introduced in this area, please let me know.
Yes, yes, definitely. Sir, we are having separate steel methoding team. So definitely we will in touch with them and they will share their experience with you also. Like iron, now we are expert in iron. Like steel, we are having separate team. They will. They definitely for duplex also we have some methoding solutions. They will share with you.
Okay. Is it possible to see the or mobile number so that they can contact me?
You can just drop your contact number on message chat. We will ask our team to discuss with you.
Okay, no problem.
Okay, sir. Thank you. Thank you very much. First and foremost, actually, I extend a heartfelt gratitude to our esteemed speakers, Mr. Rohan Joshi and Mr. Nitin Patil, whose expertise actually have truly enriched our understanding on today's topic, actually enhancing casting quality and productivity through optimized methoding solutions. Your thought-provoking insights and practical takeaways has sparkled meaningful conversations and left us with much to reflect upon. Thanks to all the participants for your enthusiastic presence and engagement. Your questions, comments, and curiosity brought meaningful interactive experience actually to all of us. And thank you once again. And we look forward actually to meet you in upcoming webinars too. Thank you very much. Thank you, sir. Thank you.
Thank you. Thank you. Yes. Thank you, everyone.
Thank you.
Thank you.
Thank you.